So now let's solve another exercise. This is exercise number 3. It's taken from Hibler's textbook, exercise 1398 from the 14th edition of the textbook. So what we have here, we have a mass of 2 kilograms, and this mass is being pushed up by the arm OA, so that the mass can go upward, but it is confined to move only in the vertical direction. They said to me also that this slot is smooth, so if it is smooth, it means that no friction forces. Okay. Now they said to me the arm OA rotates so that it can push the mass, the 0.5 kilogram mass, upward in the vertical direction with constant angular speed of 2 radians per second. Now the question is, find the force of the arm OA that is exerted on the mass at theta is equal to 30 degrees. So let's try to solve this problem together. So what we are looking for is a force. Since we are looking for force, we will need to set up the equations of motion. And to set up the equations of motion, you will need free body diagram. So the first thing we should do is to draw free body diagram, then set up the equations of motion, then compute the forces. Okay, so this is step number 2 and this is step number 3. So let's understand the problem here. Let me just draw here in gray color. So what we have a vertical slot, and we have the arm OA. Okay, so this is the arm OA. Now that we have the arm OA and the slot drawn, I draw them here in gray color just to signify the fact that I'm going to remove them and replace their action using forces. So I draw here the mass, but pay attention how I draw the mass. So the first force that I represent here is the weight. Now look here carefully. First, the arm OA will exert a force on the mass. So that force will be perpendicular to the line drawn from O to A. So I will draw that force. So this is the force of the arm OA that is exerting on the mass. I have to show here that it is perpendicular to this arm. The other force, I'm going to draw it in red, is the force of the support. So we have to be very careful. Imagine that this side of the slot doesn't exist. What will happen to the mass is that when the arm OA exerts a force in this direction, this mass will just fall. So it is very important to have this support. Since it is important, I'm going also to remove it from the environment, I have to represent its action using a force. So in this case, we will have a reaction force due to this support. Okay, on the it is an action that is applied on the mass. Okay, now what happens is that the mass is trying to push this support here, trying to push the support due to the application of the force by the arm. So the support will push back. The support will push back by another force like this. Okay, so let me clear this and show where is that force. So the force will be in this direction like this. So this is the force M. This is the reaction of this side of the slot. Now that I have the free body diagram, I have to choose now the best coordinate system to set up the equations of motion. So simply due to the fact that I have been asked to calculate the force at a specified angle, and I was given the angular velocity theta dot is equal to radians per second. In this case, I need to use a cylindrical coordinate system. In this case, we are going to use a polar coordinate system. So let's show the axis. So I prepared here two vectors to show the radial, and so this will be the radial axis and the transverse axis. So the transverse axis will be perpendicular to the radial axis, and in this case the force FOA will pass through that axis. So this will be the transverse axis. I was given also this angle theta is equal to 30 degrees. Clear? Good. Now I need just to set up the equations of motion. I'm looking for force FOA. So that force FOA is in the direction of the transverse axis. So in this case, I will set up the equation of motion only in the transverse axis. So we have sum of the forces is equal to the mass times acceleration. So in theta direction, or the transverse direction, we have sum of the forces in the transverse direction is equal to the mass times the transverse acceleration. So what are the forces in the transverse direction? We have FOA that we are looking for. Then we have two other forces or components of the forces, the W and the weight and the normal reaction force of the left side of the slot wall. So we have this component on the radial axis and this component on the transverse axis. So I'm interested in this component. So this component is simply W times, so if this is theta is equal to 30 degrees, I'm going to have it also here. So this also will be theta. So I have this component of the transverse axis of the weight. We have W times cosine theta. Likewise, for the normal reaction force, we have two components, one on the transverse axis and one on the radial axis. We will take the component on the transverse axis, it will be negative. Okay, it will be negative, and its value will be n times, if this is theta, then this angle will be also theta. So it will be n sine theta, n sine the angle theta. So the sum of the forces in the transverse direction will be FOA minus the two components of the weight and normal reaction force on the transverse axis, so minus W cosine theta minus n sine theta equals mass times the transverse acceleration. So what I'm looking for here now is FOA. But the issue is that I don't have the normal reaction force and I don't have the transverse acceleration. So I have two unknowns. So let's start with the normal reaction force. The normal reaction force, it has another component on the radial axis, right? Since it has another component, so I'm going to go and express the equation motion in terms of the radial forces. So on the radial axis, we have some of the forces in the radial axis. Some of the forces in the radial axis is equal to the mass times the radial acceleration. So what are the forces in the radial axis? We have first no component of FOA on the radial axis, so I'm left only with two components, W. We have W sine theta, and we have another component, so this is negative, and we have another component of the normal reaction force on the radial axis. So this is n times cosine theta, and it is positive. So some of the force in the radial direction will be what? Will be negative W sine theta plus n cosine theta is equal to the mass times the radial acceleration. Good. Now let's look at what I'm looking for. I'm looking for n at the moment, but I don't have the radial acceleration. I don't have the radial acceleration. So how do I find the radial acceleration? Assuming that I found the radial acceleration, I will calculate n easily from this equation. Now, if I calculate n, I'm still left with the problem of the transverse acceleration. So now I have two equations, but three unknowns. What are the three unknowns? FOA, that I'm looking for originally, AR and A theta, the radial and transverse accelerations. Now recall from kinematics that we have AR and A theta equal to AR equals R double dot minus R theta dot square, and A theta is equal to R theta double dot plus 2 times R dot theta dot. So I'm looking for AR and A theta, but here is the problem. I don't have R double dot, I don't have R, and I don't have theta double dot, the angular acceleration, and I don't have R dot, which is the component of the velocity in the radial axis. So I need to find first now R as a function of theta. Okay, we need to find R as a function of theta. Now if you look at the dynamical system, we have like a triangle with the sides 0.5 and we have here R and we have this angle theta. Okay, so what we do, we can draw here our triangle. We have here R and we have this angle theta, and this side length is 0.5 meters. So if you calculate the cosine of the angle theta, what we have, cosine theta is equal to the adjacent, which is 0.5 divided by R. So this means that R is equal to 0.5 divided by cosine theta. R is equal to 0.5 divided by cosine theta, or R cosine theta is equal to 0.5. So if I put theta equals 30 degrees, I can calculate R is equal to 0.5 divided by cosine 30 degrees. And this should give me about 0.577 meters. So what remained here? We still need to find R dot and R double dot. So we have from this equation R cosine theta is equal to 0.5. So we have R cosine theta is equal to 0.5. So if we differentiate with respect to time, what we get? We have here the product of two functions. So the derivative of the product of two functions will be the derivative of the first function times the second one plus the derivative of the second one times the first one. So we will get R dot cosine theta plus, you put back R, then you differentiate cosine theta. But differentiation of cosine theta here is with respect to time. So it will be minus sine theta times theta dot is equal to, what is the derivative of 0.5? With respect to time is 0 because it's constant. So from this equation, we can calculate R dot at theta is equal to 30 degrees. Okay, so this will be equal to about 0.67. Then we can calculate also the second derivative of R with respect to time. So what we do, we'll take again this equation and we differentiate it with respect to time. So what we will get? Let's simplify it first. We have d over dt of R dot cosine theta minus R dot sine theta is equal to 0. So what we have here is the sum of two derivative of the sum, so it is the sum of derivatives. So this means d over dt of R dot cosine theta minus d over dt R theta dot sine theta is equal to 0. So let's start piece by piece. Start with this, okay? Then we go to the second one, which is this. So here what we have the derivative of the product R dot and cosine theta, so it will be the derivative of the first one times the second one plus the derivative of the second one times the first one, so it will be R dot R double dot cosine theta plus put back R dot times, what is derivative of cosine theta with respect to time? It is minus sine theta times theta dot. Good. Now for the second one, it's a little bit involved. So we have the product of three functions, R, theta dot, and sine theta, and we want to find the derivative with respect to time. So what we do, I will just divide it into two pieces. So the first piece is this, and the second piece is this. Now for the first piece, what we have, let's divide it. So we have d over dt of R theta dot times the second plus R theta dot, we put it back, times the derivative of the second function, which is sine theta. Now we go to d over dt of R theta dot. So this is the product of two functions, and we can calculate the derivative of this function or of this product with respect to time easily like we did before. So it will be r dot theta dot plus r theta double dot. Now don't forget that it is all multiplied by sine theta plus r theta dot, this is one, times what is derivative of sine theta with respect to time? It is cosine theta times theta dot. So if I simplify this, it gives me r dot theta dot plus r theta double dot times sine theta plus r theta dot squared times cosine theta. And I simplify this, gives me r double dot cosine theta minus, so this is actually equivalent, minus r dot theta dot sine theta. Now we have this part of the equation minus this part shall be equal to 0. Okay, so the whole thing now will be equivalent to minus r theta dot squared cosine theta. It has to be equal to 0. So if we calculate from this equation, we calculate r double dot after simplification all this, we get r double dot is equal to 3.85. Okay, almost 3.85 meter per second square. Now that we have r dot, r double dot, and we have theta is equal to 30 degrees, theta dot is given to me as constant 2 radians per second. So theta double dot, by the way, is equal to 0. Why? Because simply theta dot is constant. So the angular velocity is constant, so the angular acceleration will be 0. I have all this information, then I can go back here. So I can calculate AR and A theta. Can say here that I have this guy, I have this guy, I have this guy, and I have this guy. So I should be able to calculate AR and A theta. So let's go back now and calculate AR and A theta. So AR is equal to r double dot minus r theta dot squared, and A theta is equal to r theta double dot plus 2 times r dot theta dot. Again, this is 0. So this should be equal to 3.85 minus r. We calculate r is equal to 0.577 and times theta dot, which is 2 squared. And this shall give me about 1.54 meter per second square. Now, likewise, A theta is equal to r theta double dot, which is 0, plus 2 times r dot, we just calculated, equal to 0.67, times theta dot, which is 2 radians per second, and this gives me almost 2.67 meter per second square. Okay, good. Now that I have AR and A theta, I go back to these two equations. So we have here equation 1 and this is equation 2. We have AR, we have A theta. So we are left with two equations with two unknowns, FOA and M. I can solve equation 1 and equation 2. So solving equations 1 and 2, it gives us the final answer, N and FOA. Remember that we are looking only for FOA at the moment, but as a byproduct we get also the normal reaction force, N is equal to approximately 3.72 newtons, and the FOA, which is the force of the arm OA that is exacting on the mass, is equal to approximately 7.44 newtons. And this concludes the solution to exercise number 3.